and I'll cover warnings and diagnostic stuff, and then Jakub will cover the optimization for 5 and C++17 and stuff like that. So, and a couple of points before I dive into those new warnings. I'm not gonna cover all of those new warnings because some of them I don't really know all that well, and some of them are those ones that I don't like very much. So this is not a complete list. For the complete list, please see the GCC page, and there should be a changes page where you can see all those new stuff. Another thing is that this is going to be only about C and C++ because I don't really know any other language, and we don't generally care about Fortran that much. So sorry if any of you like Fortran or Ada or Go, then it's not going to be too interesting for you, I suppose. Anyway, some of those new warnings will be enabled by default. Some of them you need to enable by W all or W extra, and some of them you'll have to enable specifically. So don't be surprised if you don't see them very much, because some of them have too many false positives or have some certain problems that are too hard to fix, so you'll have to enable them specifically. Now, I'm sure that not all of you will like those new warnings. Maybe you'll hate some of them. Maybe you even hate those warnings I wrote, which I won't take personally, but it's okay if you don't like it, that's fine. You can either turn the warning off completely by using -w now and some stuff, or you can also use like GCC, Pragma GCC Diagnostics, and you can disable the warning for like just a block of code or a function. But if you do find something that bums you out, please do open PR, because sometimes we even fix things. So please don't be afraid. We need those reports. I really appreciate them. I can use this. Well, so the first warning is probably the most controversial one. Actually, when I first posted a patch for this warning, the reaction was, "This is purely evil," and that was really encouraging. But anyway, over time I fixed a lot of stuff, and this warning is now in. So it warns about switches when one case falls down to another. Like on this test case, it's clearly a bug that the case 1 falls through to case 2, and the warning would warn. So it should be able to catch mistakes like that. But for the warning to be really useful, it needs to handle various control flow statements, such as ifs. So, nice. So it handles if-else chains. So the warning is able to figure out that the first branch cannot really fall through because of this break, but the second branch can actually fall through down to case 2, but the third branch cannot fall through. So it would say like it can fall through from this point down to case 2. So it should be quite clever. On the other hand, there are some stuff that it's really hard to handle. I mean, like sometimes it's hard to gauge whether a loop can terminate or not, because this is all compile stuff. So it's not foolproof. Now, of course, sometimes you actually want the fall through to happen, and in that case, you need to say to the compiler that you really meant it. Like, think of DAF devices where you rely on the fall through all the way down, depending on some size. And in such case, you can, in C, use a null statement with an attribute, and the attribute is fall through, so the compiler won't warn. Now, in C++, you can use, in C++11, you can use the square thing attribute stuff, which is in standard C++11. And standard C++17 says that it's actually standardized, so the fall through in square brackets is standard thing. So if you can, please use that. If you cannot, then you can use the attribute, or you can use a fall through command, which is something we had discussed a lot, and it really, you don't want to know I mean, this is insane. So, well, I mean, because this fall through is nice, but then some other projects use this, or this, or this, or whatever else, and it's really never ending. So we decide.
Projects even want any kind of comment.
Yeah.
And we actually support that too, but it's
Yeah.
really strange.
Yep, because we cannot afford to do like syntactic analysis. So if it's
NLP.
I'm sorry?
NLP.
No way. I mean, we could, but no. Because some people complain like, okay, but this is just English, so what if I write it in French and whatever? and it's just impossible to handle all of that. So we decided, well, actually, it's Jakub's idea. We have 5 levels of the fall-through warning, and I think the level 1 just accepts any comment. So if it sees a comment, then it assumes that, before a case, then it assumes that it's a fall-through comment. But on the other hand, if you use like the level 4, then it only accepts like, I think, the first one or something. Just a few of them. Otherwise, there's
level 5 doesn't accept any comments.
Yeah, because some people wanted it that way.
What was the default comment?
Default is 3.
Something in the middle.
3. Yeah, it's you would have to.
Yeah, if there is fall and through with various spellings somewhere,
Yeah.
anything in between or something like
Yeah,
that.
and it could be a.
And
Yeah, and it handles 2 spellings of through, so it can be like through with O, U, or just, you know.
And what if the comment is like,
lowercase, uppercase.
we don't,
Yeah,
we
and
don't want to fall through?
That's a good point, actually.
So some of the levels we accept that as fall-through comment.
Some,
in other levels.
yeah.
So the project has to choose.
Yeah, but I'd like to point out that this warning is only enabled by WXtra, so not all packages will actually come across this warning, but I mean, I did Fedora master build and it wasn't so bad actually. You know, a lot of packages failed because of that, but it was less than I thought it would be.
I would add last thing that one unsolved thing for the comments is that when you actually pre-process the services,
Right.
comments are lost. We don't have a solution for that right now
Yeah.
because it's kind of strange if pre-processing will leave comments in the source. But otherwise, there's no way
Yeah.
to preserve it. So.
Yeah. Speaking of bugs, like I told you, we handle control flow statements. I kind of lied because we don't handle nested switches, which is something I was reluctant to do, but I think I will have to do it. Probably before we release the GCC7, so it should handle nested switches too, but no promises. Well, W-pointer compare is another baby of mine, which I don't really like the name of it, but it's too late to change the name. It's pretty simple, it just warrants if you compare a pointer with a 0-character constant or 0-character literal in C++ if you want. It basically means that it's likely that you forget to dereference P here. Or typically P is an array and you forget to use square brackets and the element number. So,
Or you wanted to write null, but you just...
yeah, I mean, why would you use 0-character constant instead of null? I mean, you could, but it's weird. And actually, this code is invalid in C++11 for the reason it's, as you can see. So many packages will fail because of this too. Now, duplicated branches is, I think, useful warning because I made it, but it warns if you have identical branches. As you can see, it really makes no sense to have this condition. If this is correct, that these two are same, then it doesn't make to really have the conditional, so you can just use return x plus 3. And it also handles conditional operators too. So it really doesn't make much sense, I think. Now there is some problem with macros. I won't really go into any details, but if you use a lot of macros, then it can have some false positives, so you'll have to enable it specifically. WRFStrict is warns when you break the assumption that a restrict qualified parameter aliases with another argument. So in this case, you have foo that takes two restrict qualified pointers, but actually you pass them the same address, which is invalid because the compiler could optimize out a lot of stuff and it could misbehave. So that's another warning. I didn't make it this time. W-alloca larger than n is if you want to find unbounded alloca uses or allocas that might use too large argument, because as you know, alloca just moves the stack pointer. So if you use alloca with too huge argument, it could smash your stack or whatever. So we have an option for that now. And so in this case, if you use the limit 500, the compiler would warn because it can see that, it can figure out that in this code path, you could call alloca with like 600 or something. So it would warn. And if you don't have this condition at all, it would warn too, probably. So it can find a lot of bugs, and the same option exists for a variable length arrays too. It's just WVLA larger than.
And there is also WAlloc larger than, which is for the malloc.
Yeah, and then there's WAlloca 0 that warns if you call alloca with 0, and then there's WAlloca that warns for any alloca.
And when it comes with, when the argument comes from runtime, like from the user? Or
then too bad, then we cannot. No, I think no optimization is apparently able to. But if it can figure out, then it would warn.
And then I make like buffer with path max size, which is 4K, you will warn as well? Or?
Well, it depends on the limit.
Yeah.
If it sees if the compiler, this warning uses value range propagation, so if it sees the argument must be within this range, and this range is smaller than the one asked for.
So it applies for any stack allocation, right?
Well, it's really about if you can hit a code path with alloca and the compiler can prove that it can have argument over the limit that you specified, then it would warn. If there is a path that leads to alloca call, then it should warn. Okay. Well,
I think his question was about like if you do the same as a variable allocation as a stack as an array, for example.
Yeah, that right.
And there is another warning, but
Yeah, it's pretty much the same, but I probably should have made a slide about it, but I didn't. But it's the same thing, basically. Well, another thing is memsetoutsize, which warns for memset calls if the first argument is an array. This is A here and A of n elements. But the third argument is actually the number of elements, but not the size of this array, which is clearly a bug.
as long as the array is not char.
Yeah, of course. Int could be probably whatever, but in this case it is probably a bug. So the compiler would warn, and you should use size of the size of an element of the array.
Does the same apply to the move?
No, I don't think so, because it's wmemset, so I suppose it's not for memmove, or I don't think so. I think it's just memset so far, but maybe it could be a good idea actually.
What does ELT mean?
Element. I didn't name it. It could be, I don't know why it's not element, you know. Yeah. Okay. Sorry. Another warning is wint in bool context, which would warn about suspicious uses of integer values in Boolean context. So in this case, it's stupid thing. So in this conditional, the conditional doesn't really make sense, because it will evaluate you true every time, and I don't think that's what you want. So the compiler is able to warn in these situations. W-switch Uninsurable warns if you have an executable code between switch controlling statement, which is cont, and between the first case. Clearly, the assignment here will never be executed, so the compiler will warn. But I need to point out that you can still have declarations here. That would work. The warning wouldn't warn. It's valid to have declarations here, just not initializer or assignment or any other code. It will never be executed, so the compiler will warn. And we also worked on diagnostics. So the compiler will be able to offer more fixed hints. It will say basically, maybe you meant to write something like this, and it will provide you the actual code. So in IDs like Eclipse, it will be able to fix it basically automatically if you allow it to. And it's also now able to give a hint about if you misspell function names. So apparently we have declaration of foobar, but we used foobar with an underline, so it will say did you mean this instead of this? So that's pretty cool. And it also handles like macro names, and it handles some other stuff basically, but yes.
It also handles command line option names and
attributes. And there's an option that is Diagnostics can automatically emit a patch. So it's for IDs. I don't know. I've never tried it, but there's this option now. I think it is Jakub's place now. So here we go.
Okay, so one of the major new features in GCC7 is almost complete support for C++17, which is still moving because, while C++ moved to those 3 years distance between releases, there is still at least one C++ meeting now in February, which is going to vote some minor changes into the standard again before it's going to be approved, hopefully. So GCC7 right now implements all the core features of C++17 as the first compiler. But of course, some new features can get in, and we will have to either implement them or put it in 7.2 or something. And on the library side, we have almost all features there. We have a web page which lists the features implemented and GCC versions, which were the first to implement them. And on the library side, you will see a couple of small issues not implemented yet. And from the major changes which are still missing is that the file system library is still available as a TR in GCC7 and not as the part of the official standard. So it's not in STD namespace, but it's TR. So it's also not in libstdc++so yet. It's a separate library which you link, and it's A only. And it's still not completely ABI stable, and it can change. So I would like to just point out a couple of
recently implemented changes which were not in GCC6. One of them is structured bindings, which allow you to split a tuple or a structure or array into a couple of subvariables. After auto keyword, you can actually put the ampersands to make it a reference or R value reference, and then there is a list of identifiers between the square brackets, and this actually, depending on what type this foo has. In this case, it's a tuple, so it uses the tuple element and tuple size to determine the size, the number of elements there. And in this case, it initializes 3 variables. One will be int, one will be long, one float, to those values from the tuple. But it can, when it's a structure, for instance, the requirement is that all the non-static data members are within the same class or structure, or in some base class, but all of them have to be in the same structure, and all of them have to be public. And in that case, all the elements here are assigned in the order they appear in the structure. If you have array, then you assign basically those identifiers are not in that case variables, but references to those elements of the array, and you can use those in the code later on. Inline variables is another thing which works kind of like static variables inside of inline functions. Basically, you can each translation unit can have its own variable definition, and all those definitions are put together into a single variable. And the requirement is that they are initialized to the same thing. Well, they are the same thing. They have to have the same definition. The main reason for adding inline variables was the problem with static const expr, static data members inside of structures, because in C++ 14 and earlier, if you write something like this, this is only a declaration. And so as long as you use the static data member in normal context, you just use the value, that's no problem. But as long as you, for instance, take the address of the static data member, then suddenly you need to have a definition, and you need to have a definition in a single compilation unit. So you need to put const int as b semicolon somewhere in a single translation unit. So this is no longer true in C++ 17, because static data members which are const expr are in C++ 17 implicitly inline variables. And so this is actually a definition and not a declaration. Declaration later on is accepted, but it's not really required, and this means you can use it anywhere else. Const expr if is another new feature in C++ 17. The requirement is that the condition actually is a const expr value, so it has to be a Boolean which expands to either true or false through the const expr folding. And the difference between normal if and if const expr is that if you have some templates and so on in the then or else block, then those are not instantiated if if the condition is true or false, depending on which block it is. So you can actually write, well, it has to be valid C++ code there, but the statements are, the C++ standard says they are discard. And so basically they are parsed, but they are not actually instantiated and evaluated and so on. Another feature is basically a syntactic sugar for being able to declare variable inside if or switch or what else? For, I think, while, if, and switch. And what this does is basically as if you put another scope around the whole if and declare the auto variable there, and then you use it in the condition. And but if you write it this way, it makes it shorter, and there is a single difference between writing it in a separate scope around the if, and that's that this variable is in the same scope as variables declared here and variables declared here, right? If you don't use the brackets around. So if you declare here another variable with the same name, it's an error, and if you declare it here, it's an error as well, because it's the same scope. This one is probably more important for the various package maintainers. C++17 finally removed the dynamic exception specification on functions. So in C++ 98 and later on, you could say that this function throws int or any class or whatever. And at runtime, there would be a checking whether, if you throw some exception, there would be runtime checking whether the exception matches the dynamic specification, and if not, your program would be terminated. So you can't write this anymore. And the only thing that is still allowed is use the C++11 no except or no except and in the parents write true or false or some Boolean expression. This one says whether the function can throw anything or can't. It's just what you use most commonly. Basically, you just say this function can't throw or can throw. And while throw in C++ 98 and so on was also a dynamic specification where it said that the function can't throw anything and terminated the program if you throw something. This throw is still accepted because it's used all around in all the headers, like all the glibc headers for most of the functions that can't actually throw an exception or be cancelled through pthread cancellation. Just have this through some macro, and it's used in many headers. This is still accepted, but in C++ 17 it's an equivalent of saying no except. So it has slightly different behavior, but for most of use cases you really don't care. But if you use throw with something else, you need to rewrite it to just drop the throw. Another thing which is very useful is that there are now new and delete operators which accept as another argument the alignment. And if you have some class or object which needs big alignment, it uses vectors inside it or whatever, then or uses align as and such attributes, then then the compiler will, as long as the alignment is bigger than the default, then the compiler will actually use these operators which have the extra arguments. So if you override the system library new delete, you probably want to override the new operators as well, and then just use POSIX memalign or whatever function provides you allocation with the alignment also. And the requirement is that, of course, anything you allocate with the new with alignment argument, that it has to be deleted with the same operator or corresponding operator. Another feature is that C++17 added some requirements on the evaluation of operands. GCC now has this new option, which has three possibilities. It can be equals none, equals some, and equals all. Strong eval order equals all is the full requirement of C++17, which means that there is a constraint on the member access, array subscripting, shift expressions, and assignments. And sum is just a subset. I think it's shift expressions and member access. And none is what C++14 had. Basically, everything is undefined. The order is undefined.
Which one is default?
It depends on the language which is chosen. We still default to C++14, so the default is strong eval order sum. So shift expressions. The reason why this has changed is that many people write in C++ use the shift operators a lot and write huge expressions with them, and really expect that the left side and right side are evaluated in some order. But in C++14, the order is undefined, and if you have some side effects between them.
When I enable this strong eval order from C++17, then will I get any warnings? Or
No, there are no warnings. It's just about what if the order is defined, that side effect. For instance, if you have member access, this means if you have something square bracket and some other expressions and square bracket, then the left side evaluates first, and what is inside the square bracket, the index, evaluates after that, if it has side effects. No, that's array subscripting. Member access is, again, if you have A.B or A arrow B, then A side effects evaluate first and then B. And for shift expressions, it's again left to right. First you evaluate the left operand of the shift and then right.
yes,
And
if a compiler can see that there are some conflicting side effects.
well, we have those. What's the name of the warning? The sequence point warning there is. But this just says that that the order is not undefined in that case, and it's well defined. For assignments, you first evaluate the right side and then the left side, which is initially the C++ committee wanted to make also the order of arguments inside of a function defined, so it would be left to right. But after some analysis, it was decided not to do this because some compilers emit arguments right to left, and it's more efficient to do it that way, and some other compilers do it the other way, and sometimes it depends on ABI and whether you have push pop and stuff like that. So another extension is that you can, for non-type arguments of templates, you can actually use auto keyword so that it can be an integer, or it can be also auto and asterisk or something like that, or auto reference and so on. Yeah.
Regarding arguments of functions, I understand that they can be evaluated left to right or right to left, but there is a way, at least, to guarantee the order, left to right or right to left.
No, the C++ standard says no, they are undefined. The order. If you have side effects in all of them.
It's worth to consider, you know, just to accept consistent behavior.
So the question was if we could require, for instance, at least left to right or right to left ordering. Yeah, but I'm not on the C++ committee, so that was something C++ committee decided.
It can be a feature of GCC, just extension.
Well, but one compiler will do this, another compiler will do something else.
Just to be consistent. Since
Well,
right now, the standard doesn't guarantee anything.
Well,
But if you
Start in the middle and.
but if GCC will be consistent, so left to right can be optimal for x86, but on architecture it can be opposite.
I think in GCC it's right now driven on some backend macro or target hook.
Perfectly okay. Compiler can choose left to right or right to left, but in the consistent way of the same system, not start.
On the same system, it's actually, that's what GCC does, but we are not going to guarantee it for you because it can change anytime. It's better not to write side effects in between function arguments, but if you use, for instance, the shift expressions the way most C++ folks use them, now you have a guarantee. So.
That's strange, since you, in this extension, you did address the same issue. It's strange why you don't address it for function argument.
Because there were measurements and showed that requiring left to right order was too slow and for some architectures. And
there is actually a case where mixed ordering can make sense. It's if you have partial register parameters where some parameters are in registers and some on the stack, then you may want to do the stack parameters and opposite orders and then the register parameters.
Optimal way, right to left on PowerPC, left to right, but
you can have for the same function you can have some parameters on the stack and some in registers.
well, the guarantees come from the C++ committee, so that's their decision. And what GCC does is, it's always because GCC right now uses the Gimple as the first intermediate language. Then we already use some order this way or that way because all the side effects have to be visible in the Gimple language, and then it's lowered. So it's not like in the 15 years ago when this was really dependent on the details of the evaluation of the arguments, but still there is no guarantee from the committee, so you really should not depend on it.
still that's strange. You do it only on the F strong eval order, not by default, right?
Well,
Nothing to do with what standards say.
Well, C++ 17 requires defaults to strong eval order all, so it requires all these.
Yeah, but for C it's not required, right?
For C, it's not required, so C doesn't try to. It actually, in some cases, this order, even this order slows stuff down, because you have evaluate something first, and sometimes you have to use a temporary variable for something or so on. Sometimes you manage to optimize it away, but sometimes you can't. Anyway, this is C++. Let's go to some of the new optimizations. Of course, there were many changes to all the other optimizations. So this is just the major new optimizations. One is store merging. If you store constants in adjacent memory, like and the fields are actually small enough, then sometimes it's worth to combine all the 4 stores in this case into a single store of a single constant. Or the store merging path actually can work also with bit fields and stuff like that. Or later on, it can be extended also for some operations on bit fields. If you, for instance, use logical bitwise operations on all the bit fields, then it can combine them into a single operation and so on. Then there are two new interprocedural optimizations. One is GCC in constant propagation actually computes also a bit mask, which bits in each variable or value are known to be 0. And many optimizations can actually use this information to optimize. For instance, if you know the low 3 bits of a pointer are known to be 0, then you know the pointer is 8 bytes aligned or stuff like that. And so we now propagate this information across the call graph. So if some function is always called with the values in the parameters which have 0 in 3rd and 5th bit, then we can actually use it and so on. And for value range propagation, we also propagate the value ranges. If you know this value has to be bigger than 100 and smaller than 200, then again, if it's an argument passed to some function or returned from a function, then we can optimize that. Another optimization is the loop splitting. If you have a loop, and inside that loop there is a condition, and you have separate blocks depending on that condition, and the condition is true or false for one side of the iteration space and opposite for the rest of the iteration space, then we can actually split it into 2 loops which don't have to check the condition anymore. Code hoisting this is not a new path, optimization path, but just part of the partial redundancy elimination. And code hosting tries to move evaluation of expressions earlier into path where we know we will compute the expression later on, and it usually decreases the code size quite a lot. Otherwise, sometimes it also speeds function up, but not always. So another new feature in GCC is support for WRF5, which is going to be finally released after how many? 6.5 years or next month. And this is implemented under GDWRF5. It's not on by default because the consumers, GDB and other consumers are still getting the support, or you would really need to have the latest utilities to consume the debug information. So we will switch the default maybe in 2 years, but for now, if you want to use WRF5, you can use this new option. There are various GNU extensions which we have implemented over the years, were actually accepted into the standard with some changes. So that's what we have implemented for almost for free, because it was just renaming of stuff and so on. The location and ranges sections were replaced by sections where you actually can use fewer relocations, and it can be actually smaller and so on. There are some new tags and attributes for C++ 11 and 14. Debug types sections were removed from the standard again, and it's now a new kind of units inside of debug info. And debug line section is now more variable. You can actually specify what kind of fields you have in the address for the files. Another feature which has been already in GCC6 and 5, but has been extended is OpenMP support, and especially OpenMP offloading to GPGPUs and other offloading devices. What is new in GCC7 is that you can now offload OpenMP code to NVIDIA PTX. And we actually, this is the first offloading we actually package in Fedora. So you can actually install 2 packages which are built alongside with GCC and have to use the binary blob libcuda from somewhere else. We just DDL open it, and then you can offload your code and compute it on the GPGPU. For AMD, there is support as well, but we don't package it because the upstream kernel driver does not support what we need for that. And for Xeon Phi, I'm still looking for access to such host because I had access to KNL, which is the main CPU of the processor, but not the offloading card and the PCI card. In the sanitizers, some of the changes were that we now can actually at runtime diagnose if you use variables, load variables or store variables which are outside of their scope. For instance, you take address of some local automatic variable, and after you leave the scope of the variable, you actually dereference the pointer. And so that's undefined behavior in C++, of course. And actually, GCC has been optimizing that for quite some time, but we didn't have any diagnostics of these bugs. Because GCC, at the end of scope, if the variable is addressable, we put a clobber which is assigned to GCC that it can throw away all the stores to that location because it's going to be removed or inside of destructor and so on. And integer assigned overflow diagnostics now diagnoses vectors as well. And that's all. I would like to say that GCC7 landed into Rawhide yesterday, so if your package is no longer built, I would appreciate cooperation and just file bugs. Well, we would appreciate if you could first analyze those bugs yourself, and if you find some issues which you believe are GCC bugs and not your package bugs, then of course file bugs either in our Bugzilla, or if it's upstream GCC, it can be upstream GCC as well. But because usually you know your package is better than it might be faster for you to debug issues if there are on the packages side. Marek is actually performing a test master build. The master build actually has completed, but there is some analysis still ongoing. So we will post some guide how to port your packages to GCC7, which will also include all the warnings which we have listed and stuff like that. Any questions?
I have a question about this. As you talked about this memory alignment, basically GCC6 or 5 assume that on 32-bit architecture, the memory returned by malloc is aligned to 16 bytes, but in practice it is aligned to 8 bytes. They start blaming glibc that it is bug in glibc that glibc doesn't align memory on 16 bytes, but in the past it always aligned memory only to 8 bytes.
Well, glibc guarantees. Well, the C standard basically says that the malloc should align everything on so that all the fundamental types of the language
so
are.
That is the problem because GCC added new types and specified 16-byte.
But those edit types are not part of the standard, or they are gray area. So basically, you have to count with the what the glibc does basically. It guarantees you twice the size of the pointer as alignment.
Yes, but so it should use the unaligned SSC instruction.
If you use vector types and stuff like that, you should always use mem-align, POSIX align, or C11 has aligned alloc, or in C++70 now you can use the new operator which will do it automatically. But it's non-standard type, so you have to do something on your own. Yes?
Can you explain why the delete also needs this additional align parameter?
That's so that you can actually implement it even on architectures where malloc is not able to do it. For instance, if on HPUX, say you don't have malloc which can guarantee you any extra alignment, and if the default delete operator uses free, then you basically have to have something which allocates you something that you can free. And so what would you do in that case? You would try malloc as many times as possible until you get something aligned. That's not going to work. And so, for instance, for HPUX, the implementation allocates the size plus the alignment and stores the actual pointer returned by malloc into word before the allocation. And then the delete operator is different because it actually reads that word before the allocation and frees that, and not itself, not the address passed by user. And on Windows you have also some aligned alloc and aligned free, and you have to pair them. Another question? Last question?
So maybe just missing something. There was the example of, or the new warning about comparing pointer to the character of 0. So why just 0? Why not any character?
Well, I would guess that people really don't use that because it doesn't make much sense.
How would you compare pointer with like
pointer equals 1? Yeah, it's
by accident, if you're missing the asterisk, you want to compare the first character and you forgot the star.
Yeah, like comparing the space, for example. Yeah.
You just still have to do the reference if you wanna.
Well, yeah, maybe it would be useful to warn in that case too.
For the other characters. It already warns for the others.
Yeah, maybe it does. The thing is that this is really common, and it occurs also in GCC sources at some point and in various packages. So people really make this kind of mistake, and it actually compiles without warning, and it compares the pointer against null. So